So starting from the left-hand side of the vehicle, this is the bottom where we have the 9 Aeon 1 engines. In our previous broadcast, we talked about these engines getting printed using powder bed fusion or PBF technology. Each of these engines has a thrust capability of 23,000 pounds at sea level. This gives us a max total liftoff thrust of more than 200,000 pounds. The Aeon 1 engine is designed with a gas generator cycle, and we have thrust vector control actuators, or TVCAs, mounted on these engines in order to gimbal the vehicle during flight. We have completed more than 2,000 engine hot fires and over 10,900 seconds of runtime across Aeon 1 hot fire tests. The Aeon 1 engines are attached to the vehicle through the thrust structure. This is what takes the load from the thrust of the engines. And above the thrust structure is the stage with WAM printed tanks. This is our wire arc additive manufacturing in-house process. These tanks hold liquid oxygen on the top and liquid natural gas on the bottom. These tanks are pressurized during flight using an autogenous pressurization system. This works by running propellant through heat exchangers mounted on our engines, which convert the liquid propellant into a gaseous state, and this is piped into the top of the tanks to maintain our ullage pressure, or the required pressure for the tanks.
All right, T-clock is rolling. We are less than 16 minutes away.
Please provide concurrence to proceed in the launch countdown with go, no go. VC. VC go. GC1. GC1 go. GC2.
GC2 go.
Ground. Ground go. AVI. AVI go. FTS. FTS go. RF. RF go. GNC. GNC go. Flight software. Flight software go. Thermal. Thermal go. Prop 1.
Prop 1 go.
Prop 2. Prop 2 go. Fluids 1. Fluids 1 go. Fluids 2. Fluids 2 go. Loads. Loads is go. Rock. Ranges go. OSM. RC.
RC go.
Vehicle. Vehicle is go. CE. CE is go. LC. LC is go. All parties have reported go for launch countdown. Once the clock begins to roll, anyone can call for a hold at any time. A hold is called prior to T-minus 70 seconds. The T-clock will continue to roll until T-minus 70, at which point a hold will automatically be initiated. A hold is not possible after T-minus 70, and any hold call after that will result in a terminal count abort. Should a hold manual be necessary, the person calling for a hold or abort should state clearly on comms, hold, 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 or abort, abort, abort. In the event that OSM requires a hold, OSM will initiate the hold command on the OSM GUI and notify LD and RC on primary net.
Rock, report range status.
Range green.
That was confirmation. The range is green for launch.
Propellant closing out.
Flight computer configured for launch.
Under 1 minute.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Ten, 9, 8, 7, 6, 5, 4, 1. Lift off.
Terran 1 has cleared the tower.
Control maneuver starting. Launch pad station.
Look at that blue fire! If you can hear me over the cheering, the vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is Max-Q, around 80 seconds.
Terran 1 is supersonic.
Get telemetry switch over at the ground station.
Max-Q.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through. Max-Q. As you can see, we were waiting for MECO and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that, we had second stage ignition, which you can see the Aeon vacuum engine in that beautiful view in the night sky. Reminder, there is no fairing for this maiden launch as we don't have a customer payload, but we do instead have a memento of the first ever circular test print.
Announcement on countdown. This is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
As you heard from our launch director, we did have an anomaly with stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at Max-Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @Relativity Space on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.